So we went over the product property and we went over the power property. So in the product property, we added our exponents together. In our power property, we multiplied our exponents together. Our quotient of powers, so our quotient property, we're going to subtract our exponents. Okay, so if we are dividing two powers, we are going to subtract their exponents. And I'm going to show you how this works out, just like we did yesterday, where we're going to write them out and then we'll simplify them, and then you can decide later on if you would prefer going right to simplifying them. So if we had example 1 here, c to the 11th over c to the 8th. What this means, so yes, you're going to want to draw one big long fraction bar. We are going to put 11 c's on the top. C to the 11th means 11, so 3, 4, 5, 6, 7, 8, 9, 10, 11. How many are we going to put on the bottom? 8, yep. Okay, so we'll put 8 on the bottom. All right, so I always try and show you the why behind, why do we subtract them? Here's why. So with multiplying, we could see this nice long line, and I could see I was adding all of them together. Here what's going to happen is I can actually cross out one from the top and one from the bottom until there's no more left on one of them. So like here, I'm going to keep crossing out until I run out of C's, and I run out of C's on the bottom first. We'll talk about what it means if it's on the top that runs out first. But here I have the bottom running out, and so how many do I have left? I got 3. And so final answer is going to be a c to the 3rd. And if you think about this math, right, I would have 11 minus 8, aka gets me that 3. Okay, so when we see this, you are going to subtract their exponents. Again, you don't necessarily have to write them out. The reason that we start off this way is because it is helpful, and you can clearly see the why behind why we're subtracting in the first place. So for number 2, I have r to the 5th, so that's 5 r's on top. R to the 2nd means there's 2 r's on the bottom. Crossing out, I can see I have an r to the 3rd. And if you think about this again, 5 minus 2, I get my 3. All right, g to the 8th over g to the 3rd. Would someone like to share what we get for that? So g to the 8th over g to the 3rd, Reese? G to the 5th. It doesn't matter if you have multiple variables. You subtract your like things. A to A, B to B, X to X, Y to Y, whatever the case is, okay? So remember, only follow with the variable that it is. So for A, I'm going to have 6 minus 3. And so for 6 minus 3, I'm going to get 3. For my B's, I have 4. Ooh, what's the exponent on the bottom? 1. Remember, I always put that there so we don't forget. And that makes that a B to the 3rd. So if I have A to the 6th, B to the 4th, over A to the 3rd, B to the 1st, that results in an A to the 3rd, B to the 3rd. What are you thinking we do with our coefficients? Reese, what are you thinking? Divide. Just like we did with the multiplying. So we still multiply. Our big numbers, our coefficients, always follow the rule that's there. All right, it's our exponents that have different rules. So we are still going to actually do 10 divided by 2 and get a 5. For my C's, we have 7 minus 3. That gets me 4. For my D's, I have 3 minus 2. You may either put the 1 or just D. Either one is absolutely fine. Okay, so you can decide what you want there. All right. Questions for me? What can we talk about? Okay. There are occasions where we have a power of a quotient, so kind of tying in what we did yesterday. If that's the case, we find the power of the numerator and the power of the denominator. You find that power goes to both things. Okay, so that is the most common error I have found, so it's a very specific part of our notes. All right, symbol-wise, what this means is if you have a power, it goes to both the numerator and to the denominator, both pieces. All right, so what that looks like here. This 2, it goes to the 3, it goes to the P, it goes to the 7. Okay, that 2 goes to everything. So I always like to start by, I'm going to rewrite this in pieces. I'm going to say 3 to the second. What do we do with our exponents when it's a power to a power? Anybody remember? So it's like the last 3 on our examples on the half sheet. Power to a power. Not add. Multiply. Yep, so we multiply. And then the 7 also goes to the power of 2. So remember, we multiply our exponents for that power. And then we actually can solve these. What is 3 squared? 9, okay. And we have P to the 6 because 3 times 2. And what is 7 squared? 49. If you're not sure, you have your calculator. We always look to see if we can simplify. So we always look to say, is there anything I can do to 9 over 49? If you're not sure, put it into your calculator. It will tell you. They are not divisible by anything, though, so it will actually simply stay 9p to the 6 over 49. All right. My power of 3. It goes to 3. It goes to the x. It goes to the 4. All of them. Goes to everything. I'm going to write it out again. So we're going to say 3 to the 3rd. What do I do with my exponents when it's a power to a power? Multiply, okay. And then I have 4 to the 3rd. All right, 3 to the 3rd. If you don't know, put in your calculator. 3 times 3 times 3, or again, 3 to the 3rd. So putting that in, double checking. Do you guys get 27? Okay. For my x's, I get 12. Ooh, what do we get for 4 to the 3rd? 64. All right, 27 over 64. Cannot simplify. And I truly am. I'm checking with my calculator just to double check. There's nothing wrong with thinking that I know I'm correct and double checking just to, as I said, double check that I'm right. So putting that in, I get that I cannot simplify. So we'll stay like this. All right, one more with the quotient and power. So what exponent is with the y? A 1. Please put them there. I promise it's helpful. All right, the 2 goes to the 5. And to the x, and to the y, and to the 6. Okay, so again, that power goes to everything on the inside there. All of it. All right, so this 5 goes to the power of 2. Ooh, what do we do with our exponents again? Multiply, okay. So 5 times 2. For my y's, it's 1 times 2. And this becomes 6 squared. All right, what is 5 squared? 25. And then I'm going to get an x to the 10th, a y to the 2nd, all over 6 squared, which is 36. 25 over 36. I cannot simplify, so I am done. You guys are going to really like. And then I have one thing that we are definitely going to spend some time practicing because it's probably the trickiest of all of the products that we do. The very one that I think you guys will like the absolute most, though, is our 0 exponent. Anything raised to the 0 power is 1. Anything. So, if you look at something like number 9, looks kind of really messy, my final answer is simply 1. Because the whole thing is being raised to the 0 power. So, anything to the 0 power is 1. You can put it into your calculator. I promise it will work. Anything to the 0 is 1. Every time. Okay? So, something that we know. So, when we get into something like number 10, we need to follow our quotient property, which we just did on the front. So, quotient property, what do I do with my exponents? Subtract them. Okay? So, for my b's, I have 5 minus 4. My c's are 2 minus 2. And then I just have this d to the 0. I have nothing to subtract with it. So, for my b's, I have 5 minus 4, so that's 1. Feel free to put it or not. It's up to you. My c's are going to go to c to the 0. However, anything to the 0 power is what? 1. So I don't need to put anything there. D to the 0, also 1. I don't need to put anything there. My final answer is B. So all of that goes to that. Now, I'm not saying that you can't put a 1 and make this a 1B1. That's a total you decision if you want your 1 there, but you don't need it. So again, this will go to C to the 0, which is just 1. D to the 0, that's just 1. So I end up with just B. So anything to the 0 power is 1. All right. This next one, we are going to very, very quickly introduce, and then we are going to spend time practicing and re-looking at this tomorrow, especially since I have a short amount of time here. This is, again, probably, in my opinion, the hardest property to get. If you have a negative exponent, to make it positive, you take the reciprocal of your base. Okay, so that base, one of the things we had talked about yesterday. When you change it to the reciprocal, your exponent turns positive. Kind of really funky how it works. For example, 2. What is the reciprocal of 2? 1/2. Okay, so, all right, 2 over 1. So we make this a 1 over 2. The exponent stays with its base, but it turns positive. So what that means is this is now going to be 2 to the positive 3 in the denominator. This is something you are absolutely encouraged to use your calculator for if you need it, okay? Because you might not know 2 to the 3rd off the top of your head, and that is absolutely okay. If you do know 2 to the 3rd or you want to work it out, that is also fine. 2 to the 3rd gets me 8, and so my final answer of 1 over 2 to the 3rd is 1/8. All right, let's take a look at another one that has some negatives here. Okay, so I have 1 over j to the 4th. Negative 4, sorry. So what happens is the reciprocal, so that now becomes j over 1. Reciprocal again means you flip your fraction. And then the exponent turns positive. All right, and so I'm done. There's nothing else I can do here. My final answer is j to the 4th. Final answer. When we see something like 13, where I have one variable having a negative and the other one having a positive, that's okay. We only move variable, like you can move only one variable and keep one variable there. So what's going to happen is this a to the negative 3rd, I'm going to make that 1 over a to the positive 3rd. And my b to the 5th, I'm not going to do anything to it because it's not negative, so why move it, right? And the one thing is you can either leave it like this, or what I like to do is actually kind of multiply them together, and so the b stays on top. So you can kind of think of this as one big fraction and the negative is going to move to the bottom. As I said, it's kind of funky. We will definitely be spending time practicing this one. Does anybody think they want to try 14 and rewriting it so I only have positive exponents? Anybody want to try? No? All right, let me ask you this. Are we moving the P? No, the P is positive. So I know for sure that's going to stay up top. Are we moving the R? No, that's also positive. Okay, so I know for sure those two things didn't move. I do need to move my N. Okay, so numerator, flipping it becomes into the denominator, and my exponent becomes positive. It's actually kind of nice when there's things already in the denominator because it just moves right with it. We're just going to end with 15 today. We'll do 16 another time. Okay, so 15, last question today. 6 minus 2. Is that positive or negative? Positive. Okay, what is 6 minus 2? 4. All right, 4 minus 7. Positive or negative? Negative. Okay, so I'm going to start by putting it as a negative. We'll move it here in a second. Sorry, now I'm just doing my quotient rule. 3 minus 9? Negative. Okay. So my A is positive, so it's staying on top. Doesn't move, it's already good to go. My B is a negative, though, so I need to move it to the denominator, and it becomes positive. And my C is also negative, so I'm moving that to the denominator and also making that positive. It's tricky. We will spend time practicing it. Okay? So